So on the table in front of you, you have some of the stuff that I'm going to be modifying and installing on the Blazer during this 8.8 swap / upgrade. Something that a lot of people aren't familiar with are what's called a leaf spring slider. Let me just show you. This is a leaf spring slider box. What this does is this eliminates your rear shackle, mounts to the bottom of your frame, and allows your spring eye to move back and forth via roller bearings. That's a sealed roller bearing on each side. Let me flip it over, because just keep in mind, this mounts to the bottom of your frame, right in line with your end of your leaf spring eyelet or eye opening. But basically, a slider, leaf spring slider, has a solid aluminum bushing, spacers, sealed roller bearings that ride on these tracks, and you basically have this motion. So when you set this up on your vehicle, you're going to, of course, remove your stock rubber bushing inside your spring eye, and then you're going to press this in. A one-word warning: these, part number 910-43305, are the ones we buy from Speedway Motors. These are actually made for Camaro. A Camaro has a larger leaf spring bushing, so this actual solid aluminum bushing is, let's see, 1 5/8, 1.625 in diameter, which does not fit an S10 spring. I do know people who have forced a 1 5/8 bushing into a 1.5 inch hole, but I do not suggest doing that, because the spring eye could actually fracture and break underneath that much pressure. So my plan is to send this to the machinist, have him put it in a lathe, turn it down to 1.510. And you might ask, well, where did I get that number? How do I know what to set it at? I basically went to my local auto parts store, had them pull a Moog replacement leaf spring bushing off the shelf, and mic'd it. So even though online they'll say that the S10 spring eye bushing is 1.5 inches, it has a 10/1000 press fit. So you wouldn't want to turn this down to exactly 1.5 inches, because then it wouldn't be tight in the spring eye, because you don't want this piece spinning inside the end of your spring. You want it to be solid in the spring, and the spring to follow this box. So it gives you far better control of your spring support, action, rebound. There's a lot of off-roaders. If you do spring I think they call them spring sliders or leaf spring sliders. If you look up sliders on YouTube, the majority of the people you see using these are off-road 4x4 enthusiasts that put them on their big lifted trucks. But racers have found that it's actually a benefit to your leaf spring action to run them on the, Camaros, Novas, S10s, any vehicle that has the leaf springs in the back. So, just to give you a little information on that, this is what I'll be installing on the back of my Blazer when I do the 8.8 swap. So there's that. I thought that, the first time I heard about these, I had no idea what they were, and I tried to do a lot of research online. And lo and behold, it's a simple design that actually improves traction at the racetrack. There's a hint for you for 60-foot times. But Speedway Motors, check them out online, order one of their catalogs for free, and you'll be able to hook yourself up with those. Just remember that difference in size. If you're not running a 1.625 leaf spring bushing, you're going to have somebody turn that down for you. Okay, the next thing I'm going to be installing on the Blazer is going to be the homemade Caltrac bars. Now, the problem we're having was that this initial design that we made several years ago, at least 2 years ago I think, hangs down too far and actually hits the trailer. Like when Richard's trying to load his Typhoon on the trailer, this thing literally hangs down so far that it hits the end of the trailer. So what they've been trying to do is add boards at the end of the car trailer to be able to load and unload the Typhoon without trying to rip these brackets off the car or damage the spring eye or whatever. So I think what I'm going to try to do is I'm going to take my set, because these were all made together, and of course I got the crappiest looking version of them, but that is what it is. So what I'm going to try to do is do some measuring and probably cut off this lower hole. Like a lot of people that run these Caltrac style, I'm going to say Caltrac style bars, because these are homemade. We can call it whatever we want. You know, everybody has their own take on it, but everybody knows what these are. But it's because this hangs down so low, and a lot of people use the second hole, because I'm going to call this the top hole and the bottom hole. Some people call it the top 1 and 2, and I don't know, it gets confusing. But if I need to, because the best position most of the time on a leaf spring car is to set that bar that goes between the mount under your rear end to your front bracket. Generally speaking, now I'm not saying this is written in stone, I'm not saying go out and argue with your friends at the track. Generally speaking, that bar needs to be level. Like when that bar is parallel to the ground at ride height, generally gives you what you want in terms of planting the tires for your best 60 foot in traction. Now you can alter your preload with your jam nuts to kind of dial them in from that point, but most cars that we've seen, they don't benefit by using the higher location. Like going to the top hole on your actual bar generally hits the tires hard and then lets it off and it makes it spin. So keeping that in mind, what I want to do is test fit these on my car. Keep in mind they go like this, because this is that little bar. These are tack welded together just so you guys don't get confused. This isn't one, this is 2 brackets. So when I test fit it on the Blazer, it'll go this direction. If this is the front of the car, this is how it's going to sit under the front spring, or beside the front spring eye. So if I can get a good level connection between my rear bracket and the front bracket in this hole, and it's level, I'm going to zip this thing off. I'm not playing that dragging on the ground goofiness. If I can get a good level installation using this hole, I will literally just cut these off. And then I won't have that loading and unloading problem that everybody seems to be having with this particular bracket. So that's our version. You can call them Caltrac clones, whatever, because everybody's got the assassin bars. I mean, everybody's got their own version of it. That is going to be going on with my 8/8 swap. So there's my front brackets. Here's 2 of the rear brackets that have a relief. If you've ever looked underneath the lower mounts on an S10 or Camaro or whatever, you have to relieve this so that when it goes up under there, it misses a part of the lower bracket. These, I think, are almost perfect in size. I'm not real happy with the hole down here in the bottom, so I might be doing a bushing there. I'm not 100% sure. But this bracket, when it's welded on to the bottom spring mount, is shorter than where my rim sits. Okay, I hope that's not too confusing to you guys, but when you have a bracket underneath your rear end with a bar coming off of it, the bottom of this bracket cannot hang down farther than your rim. Otherwise, when you get if you were to get a flat tire or a blowout, these things are going to dig into the ground. You know, if you're driving down the road and you have a blowout, and if this thing hangs lower than the bottom of your rim, it's going to dig right into the asphalt, concrete, whatever. You can't have that. So you have to make sure these will mount up under there, and the bottom of them are, I think mine are at least 1/4, 3/8 shorter than my 15-inch rim, so I don't have any problems. So I got those. This is an example of what my rear, I think the proper term for this piece is a clevis bar. So I will have this mounted underneath the back of the spring. You know, of course, they'll be separated by spacers that I don't have on there, so it'll be mounted like that. But I'll have a clevis bar with a jam nut into a 1-inch outside diameter heavy wall tubing that'll connect from this clevis up to these brackets with a pivoting. Your front piece on your traction device, we'll call it, the back one can be solid. It doesn't need to pivot or do anything of that nature. But where it connects to your front brackets needs to have that pivot built into inside of it. So I will order some, probably just standard. If I could get a deal on chromoly, I'll get it, but I'll probably just get standard cold rolled steel, 1-inch outside diameter. I think it's like 3/4 or something inside diameter, thick wall. And then I'll buy the bungs that's just basically slip into each end of my tube. They weld, and then this will screw directly into the end of the tube. I don't have my pivoting end, so these are just for, showing you that this will be on one end with a pivot. Both will have jam nuts. You'll have your bar in between. They'll connect to your front bracket. See if you guys can see that. They'll connect to that bracket. And then these are your pieces that go in between these front brackets above your spring. That is a safety feature, so that when you slam on the brakes, this bar hits the top of the leaf spring and keeps your traction device from going down and digging into the asphalt or the ground. So that's what that is, a bar that goes in between these plates right above their spring as a safety precaution for hard braking. I don't know, maybe not everybody's that familiar with the Caltrac type traction devices, but basically that's what it is. You got brackets underneath your rear end mount that basically have a clevis. This is actually called a clevis, not a pivot, or the actual term for the one that has the swivel joint, Heim joint, I think is what they call it. But you can run a clevis in the back, a true Heim joint in the front. Both have locking jam nuts, and then you have your tube in the middle, and that's your adjustment for preload. You got one hole in the back, and generally, unless you buy the lowered vehicle specific traction devices from a well-known company, they'll always have 2 adjustments in the front, which are these 2 holes. Remember, you got your 2 adjustment holes to get your bar level. And if you buy lowered vehicle specific traction devices, they only come with 1 hole. Now, whether that hole is exactly in this location, I don't know. It could be up here, over here, I don't know. But when you make your own homemade traction devices, don't cut your tube in between your Heim joint and your clevis, or if you put 2 Heim joints on there, do not measure and cut your tube in between those until you get your brackets mounted to your vehicle because the angle of the brackets, because when you make these and weld them up under there, the length of these, there's a lot of different variables that can change the end result and what you want in your actual traction device bar length. So don't go online. This is why when you go online and you try to look up, let's just say, hypothetically, you went online and you wanted to look up Caltrac bars. How long do they need to be for an S10 or a Camaro or a Nova or whatever? Hardly anybody, if anybody, will tell you any specific measurements on bar length, because even though Caltrac sends out a generic bar length for each vehicle, your actual installation could vary enough that you could have issues with your adjustments. So basically, get your brackets put on, get them spaced properly, get your front brackets on, get them bolted in, get your crossbar put on, then get you a measurement, because this will have effect on your measurements, because you want your bar, your actual traction device bar, to land about halfway up these threads. Like, you want to be able to have this as far up the threads as you can, so that you end up with a lot of adjustment for preload. Then you can run this thing down and lock it from each end, and you're good. And keep in mind, when you have a non-pivoting rear clevis, it doesn't move, so you get a lot more consistent adjustment, and the bar doesn't sit all. If you get underneath a car that has a heim joint on both ends, the bar moves around. Like, it'll be sitting different lengths, different angles, all kinds of different variables when you do it that way. They're way more consistent when you have a non-pivoting clevis or a non-pivoting heim joint in the back and a regular heim in the front, because you have to have a pivot point somewhere on your traction device. So that will be all going on the Blazer when I do my 8.8 upgrade. Hope you guys can see all this. Let me check my time here. Alright, we went over a little bit here. Anyway, that's some of the information on the homemade Caltrac bars. That's some information on the leaf spring slider boxes or slider assemblies, the benefits, and why they're going on my vehicle. So, as always, I appreciate you guys who are watching. Thank you.